finding the GCF of these three numbers right here, 12, 20, and 32. And I'm going to be using the cake method as my visual aid. So we know that 12, 20, and 32 are all even. So I'm going to use 2 as the multiple because I know that they all go into 2, or 2 goes into each one of them. So then I'm going to divide 12 by 2, which is 6, and then 20 by 2, which is 10, and 32 by 2, which is 16. And then again, they're all even, so then I'm going to divide again by 2. So 6 divided by 2 is 3, 10 divided by 2 is 5, and then 16 divided by 2 is 8. Now because we have 3, 5, and 8, there's no common multiple of those three numbers, so I'm going to stop right there, and I'm going to look at these two numbers right here. I'm going to multiply both 2's to get 4. For my second method, I'm going to be using the factor tree to find the GCF of 12, 20, and 32. So I'm going to start with 12, and we're just going to do like little lines down from it and see what can make up 12. So 2 and 6 multiplied together equals 12, and then we're going to do the same thing for 6. So 2 and 3 go into 6, and that's all we can do because we're trying to find the prime numbers, and 2 and 3 are all prime. And then we're going to do the same thing with 20. So we're going to say 2 times 10 equals 20, and then what times 10, or what times each other equals 10, so I'm going to do 2 and 5 equals 10, and right there, they're all prime, so we can stop right there. And for 32, we're going to do 2 and 16, because 2 times 16 equals 32. And then 2 times 8 equals 16. And then 2 times 4 equals 8. And then 2 times 2 is going to equal 4, so we're going to stop right there. And so we're just going to circle these numbers right here, because these are our prime numbers. And then we're going to write them out over here. So from 12, we have 2, 2, and 3. And then from 20, we have 2, 2, and 5. And 32, we have 2, 2, 2, and 2 more. And then we're going to look at what they have in common. So I know that they have this line in common and this line in common, and after that, they have no other numbers in common. So they have 2 rows of 2, so I'm just going to do 2 times 2, and that equals 4. For my third method for finding the GCF of 12, 20, and 32, I'm going to be using a formula-driven method called Euclidean algorithm. And because we have 3 different terms, to make it easier on me and you, I'm going to be using only 2 at first. So I'm going to be using the first 2 terms, 20 and 12, and I'm going to put the largest on the left side of the equal sign, and then 12, the smaller number, on the right side of the equal sign. So 12 goes into 20 one time, and then the remainder of that, so 20 minus 12 is 8. And then I'm going to move these 2 numbers that are on the right side of the equal sign down over here and make a whole new equation. And so I'm using 12 as the largest number now, and it equals 8, the smallest number. 8 goes into 12 one time with a remainder of 4. And now doing that again, bringing the numbers down that are on the right side to make a whole new equation. 8 is the larger, so it's going to go on the left side, and 4 is the smaller one, so it's going to go on the right side. And 4 goes into 8 2 times, and it has a remainder of 0. And then the last non-zero remainder is the GCF, so that would be 4. Now, going over here and using 32, so we're using the GCF found in the first equation over here and doing the same thing, so 32, the larger one, and 4, the smaller. 4 goes into 32 8 times with a remainder of 0, so then again, the GCF is 4.